Welcome back to Carneades.org. Today we're going to be continuing with our series, 6 months of set theory and higher order logic. In this video, we're tackling what is probably the most difficult concept we'll tackle in this whole first month. It is the axiom of separation, also known as the axiom schema of specification. Now, arguably, this is the most difficult concept to understand in the whole of the first 2 months, in fact. Providing an introduction to set theory is the axiom of separation, also referred to as the axiom schema of specification, the subset axiom scheme, or the axiom schema of restricted comprehension. Whew, that's complicated. It uses some unfamiliar logical terms and is counterintuitive, but it's really important to build up from looking at Russell's paradox and moving on into a basic universe. Conceptually, this axiom states that for any condition you provide, a class exists, though that class might be empty, which satisfies that condition. So the fact that I can state logically the class of all objects which are natural numbers, even and divisible by 3, means that there exists a class whose members satisfy that condition, or those conditions. They are natural numbers, even and divisible by 3. If I can state logically the condition that something must be a human, have been born in Kiribati, be currently alive, and have a PhD, then there exists a class of objects which satisfies those conditions. Remembering that I could list a set of conditions that wouldn't be satisfied by any individual, but then that class would just be empty. There would still be a class which satisfied those conditions. There just wouldn't be any members of that class. Hopefully that distinction makes sense. I'm not saying that there must exist a currently living person from Kiribati with a PhD. I'm saying that there exists a class of all of the people from Kiribati with a PhD that are currently alive. That class might have 100 members, it might have 1 member, it might have 0 members, but it still exists. At least that's what the axiom of separation is telling us. The formal definition is going to be even more difficult. The axiom can be stated as follows. For all A1, all A2, all A3, all the way up through for all AN, there exists a B such that for all X, X as a member of B is materially equivalent to the A1, A2, A3 up to AN, comma, X. Whew! What is that? There's a lot of confusing stuff going on in there. Let's try to break it down. First, it should be said that this is not actually a single axiom. That's why some of the names have called it a schema rather than an axiom. It's what's known as an axiom schema. This means that it's actually an infinite list of axioms which follow a certain pattern. So, conceptually, that's what's going on. That's why it looks a little different, and that's why there are some ... dots in there. So, on the subject of the ... dots, first, what is that first section? The for all A1, ... for all AN mean? This says that for all combinations of all classes, where AM is class number M and N is the total number of classes. So, this could just be, you could instantiate in for this just A1, a single class. You could instantiate 2 classes. You could instantiate 3. You could instantiate 5, 10, 1,000, 1,000,000, however many you want. For any combination of any number of classes that you can put that universal quantifier in front of, is what this is saying. So we can instantiate any number of classes into that block. Now what about this weird Greek letter and then a list of those classes and our X? This represents all well-formed formulas with a free X and any arrangement of the classes quantified over at the beginning of the schema. So in other words, this is all possible conditions for membership in a set that one could invent with one free variable X which satisfies those conditions. Putting it together, for any list of possible classes, A1 through AN, there exists some class B which, for all X, If and only if X satisfies a particular condition using that long list of classes, then X is a member of B. We will refer to any version of this schema as separation axiom in proofs. There's something important to note here before we go on. X in this case only represents sets. It does not represent classes. So when we quantify over for all X, we cannot necessarily instantiate any class into that. And we will prove in the upcoming videos that there exist some classes which are not sets. That there exist some classes which will satisfy everything else about being a class, but will not satisfy specifically this axiom about what a set must do. A set must fulfill this axiom in all its forms. And that's something that some classes can do because all sets are classes, but not all classes can do. Some classes are not sets, which we will show in a future video. That is what this axiom does. And it's really complicated and it's hard to realize, and we're going to do a couple more videos on it to make it really clear. But that is the point of this axiom, and it's why we use an X in one spot and a B and an A in the other. The B and the A are talking about classes. The X is talking about a set. Whew! Up next, sets, classes, and Russell's paradox. We're continuing down this fun adventure of showing why not all sets are classes, showing why we need a universal class, not a universal set, and talking about what Russell's paradox is and why it's so simple but so problematic for set theory. Watch this video and more here at Carneades.org, and stay skeptical, everybody.